Interrupted by Amber Alert, unfortunately. But it's way up in San Pedro. All right. So, where's the probability of at least one? Can you help me underline the probability of at least one? Yeah, 3. Yeah. So if I had to figure out the probability of at least one, that's equal to 1 minus the probability of none. There you go. And why is that good? Because how many ways could you have 2 people like it? Well, the first 2 could like it, or maybe the first and the last one, or maybe the last 2 could like it. Good Lord, each one of these has got multiple ways of doing it. I'd much rather do one way. There's only one way that they all could not like it. And we already did that probability in part B. And now I'm just going to do 1 minus that. Kick ass. So if you ever believe I love to do that kind of thing, yeah. Which one? 3D? Let's see. So 3D is the probability their male D, right? That one? Their male given that they own a Toyota? That's a symbol that means given. Helps us math people write less because we're lazy. What goes in the bottom of a given? What do you know about this person? They own a Toyota. So what has to go on the bottom? In this case, 59. It has to be the total number of people that own a Toyota. That's the only people it could have been. So the total number of people it could have been is 59. Out of those 59 people, how many match what I'm looking for? You with me? Out of those 59 people, how many match what I'm looking for? I'm looking for a dude. Yeah. Okay. And then you can make that into a decimal if you want to. So the only time in that kind of problem, the only time the bottom won't be 120 is if I give you more information, if I tell you something about the person. Otherwise, it could be any of the people. It could be any of the 120 people. Bless you. Yes?
With 3C, would it be 27 female, and then you add the...
It's an and. They have to be a female, and they must have a Hyundai.
So you add them.
So you can only count the female Hyundai owners. I just like to say the word Hyundai. Will Wheaton. So, it's like to see who gets that reference. How many females also own a Hyundai? 3, exactly. Out of how many total people? Because I don't know anything about the person. It's not given anything. So it's 3 out of 120. And kicks ass. In a table form, because you just go this and that. The thing I just crossed is the answer. That's the top. So they have to be this and that. Or is all these people, add them all up. Don't count anybody twice, right? And always makes the number get smaller. Because you have to be this and this. And it gets, remember me and the giant book of scholarships. Yay, shit. Yay, shit. You got to be this and this and this and this and this. Or it's like you can be this or this or this, and I'll let you in. It's like, all right, a whole big crowd of people can come in. Because if you're not this, you might be this. You guys with me? So or always makes it bigger. That's why or is addition. And makes it smaller. That's why and formally in the formula is multiplication. When you multiply 2 numbers less than 1, it becomes even smaller. But in table form, it's even easier. You just see how many people match both. It's going to be whatever I cross through. That's going to be the top. It kicks ass if you let it. All right. Anything else from there? Yes?
For 3E, wouldn't it be dependent? Because they're not dependent on each other.
Say again? Sorry?
Because they're not depending on each
All right, so dependent doesn't mean that one has to happen in order for the other one to happen. That's not what dependent means. Dependent means if one does happen, the other one's probability changes. So what's the probability that the person is a man, period? What's the probability that they're a man? Almost 46%, right? 4583. Look at part D. What's the probability they're a man if I tell you they have a Toyota? Yeah, 41%. Did the probability change? It was 46 almost, and now it's almost 41. Did it change? Totally changed. So if I tell you the person owns a Toyota, the probability of a man has changed. Now, if you're thinking to yourself, somebody's got a Toyota, it doesn't make... No, this sample happens. Now, in general, if I see somebody get out of a Toyota, and I can't tell if they're a man or a woman, I'm like, it's still 50-50 roughly, right? Toyota. But if I see somebody getting off of a Harley Davidson, now I am not about to say that there are no women who ride Harleys. That's not what I'm saying. Go with me now. If I see somebody getting off a Harley Davidson, I can't tell they're man or woman. They got all kinds of clothes on, right? They're ready for the zombie apocalypse, whatever, right? If I see them get off who do I think it is? Do I think it's a man or a woman? Most likely it's a man. So if I had to guess, if somebody was like going to die, if I didn't guess, I would say it's a man. Don't shoot him. Because it would be the highest probability would be it's a man. So being a man and riding a Harley Davidson motorcycle are dependent events. If I know one of them, it changes the probability of the other one. That's what dependence is. It's really difficult to be truly independent. Unless you have something like cards, which is not something organic. It's something like, it's always the same. It's always, if you have people, you're almost never going to get independent. Totally. But if I got cards, like we did king and clubs, they're totally independent. It's 1 out of 13 or 1 out of 13 if I know it's clubs. It doesn't change. Okay, maybe. Okay, maybe. So anything else from there? I get a wide sea of emotions out there. People, their eyes are like either desperate or they're murderous. Just class so hard, Jeff. No, I don't try to. All right. So if there's no more questions, we're going to move on. So don't forget, the quiz is on Wednesday. So the first thing I want to do is let you guys do a problem real quick like the one we did last time. So this piece of paper has a worked out example on one side. Remember, it's like the XP of X table? Oh, yeah. I'll probably just put them up on the board, make it easy on me. So on the Wednesday, I'll put formulas up on the board for the quiz. All right, I'll make it easy on me. One side is a worked out example. The other side is what I want you guys to do. It's the XP of X table kind of thing. Okay. This is section 5.2. You need to borrow a calculator, they're up there in the black bag. Sounds vaguely familiar. I've heard about it. I don't know.